Assalamualaikum. My name is Nur Najah binti Halis. I want to do for task 7, which is on cloud server. Based on question, migrate or repeat the suitable process of task 1 until 7, but to or with your choice on cloud server provider. I use 00 web host. Now let's open the 00 web host. Before that, we need to open the XAMPP, which is web server. Click on start and start. Now let's continue. Now I was logged in. Just sign in on the web host. Just for use the Google or anyone or anything email. Now let's create the new site. For me, I use IoT mini mini project. Just copy the password and put on the notepad. This is the password. This is website name. Ctrl C and copy. Ctrl V. Now let's create. Sorry, my line is so bad. Now website has been created. Just open on my side. Click on this. Hooray! That means the website is successful. Now we need to manage the website. The two important on this web host is file manager, open in the link tab, and database. Wait for a while. Let's do for file manager first. For file manager, we need to upload file. This file I was uploaded on the SAM on the htdoc file. The file list is for GPIO. We have these 5 files, and for sensor we have 4. Now just click. The important thing is you need to have these 2 files that already on here. Just click and create new folder. First is GPIO. Just create. And another one is sensor. Then create. So let's in on the GPIO folder, upload the new file. Upload the new file, select file, open the SAM folder and search for htdoc, and for the first is GPIO. Just copy for all file, open and upload. So now it's already. Next is for sensor, upload file, SAM, htdoc and sensor. Just copy all and open, upload. And now we need to manage the database. So we don't have it, we not have any database, so we need to click on new database. For database, I create like IoT mini IoT database mini. So IoT database mini project. So for password, we need to copy, Ctrl+C, and create. And I recommend to save it. So wait for a while. So before that, while we waiting for this, we need to open the htdoc file, GPIO, and open the VS Code on this 5 file. So just type cmd code space dot. And then we need to open for sensor also. CMD so now for VS Code we have GPIO. The second is sensor. So let's continue for web host. So for the web host, it's done. Click on the manage PHP admin to create new database. So now this is the database. Click on ID. SQL. So we need to copy the SQL of the GPIO and sensor. So now copy. This is GPIO. Ctrl V and click go. Put another one of SQL, which is sensor. Copy, Ctrl C and go. Now we have done create the database on the GPIO and database. So we need to change the database of PHP GPIO. We need to change the username, password and DB. So for the username, we need to copy on this, Ctrl C on the notepad, Ctrl V. This is username. Next is DB name, Ctrl C, DB name, Ctrl V. So now we need to copy on this to this one, GPIO database PHP. So for username, we copy on this one, Ctrl C, Ctrl V. For password, copy this one, and for GPIO is DB name. For DB name, we copy on this and paste on here. So now we save and close. Now we go to the sensor database. We change it. For username, we copy on this, Ctrl C, Ctrl V. For the password, Ctrl C, Ctrl V. And for the for the name is here. So now save and close. So now we go to the new tab. We need to type what's that? Mini project. We put underpad, and just put slash GPIO. So now database is here, and another one is just copy on this, Ctrl C, Ctrl V. For GPIO, we change it to sensor. Oh, before that, for sensor, we need to insert the data, one data, to avoid from error. Just click on insert. So for value 1 is just put on here and go. So now let's check for GPIO. Okay, now it's successful. And for sensor is sensor chart. Yeah, it's also successful. This have two lines, we need to delete one. Now for URL of the LED, just copy on api.php, just click and copy. Oh, before that we need to add this one, action, action esp output state. Just copy and put on the notepad. URL GPIO. Control V. URL sensor. For sensor, go back to here. For the sensor, we copy on sensor API PHP, just copy and paste. Open back the sensor chart. So now let's try to do the code program. So just delete on this. So for the task 1 is using for the task 2 is write a Python program to prompt GPIO status in Windows Outlook for every 1 second. And integrate the virtual thing above with your cloud server. Show the change of the terminal GPIO if the button is clicked. The test integration system probably uses the JSON data for request and response activity. So now let's create a new folder. Mini project 2. On the mini project 2, we have to create GPIO. Another one is sensor. For the GPIO, we have two, which is Python and GPIO Python, and another one is GPIO Micro Python. So for the sensor, we need to create two folders also, which is sensor Python. Another one is sensor MicroPython. So now let's create for GPIO first. For Python, just click on the folder and type cmd, enter, and type code space dot, and automatically in the VS Code. So for LED Python, oh sorry, wrong folder. We need to click on GPIO and cmd code space dot. For type the program, it seems like the task 2 using the Python. So let's start. So import JSON because we use JSON data, and import request because we use the request and response, and import. We use the import time because we want to create 1 second of blink the LED. So now we need the URL. For URL, we copy on this GPIO, Ctrl C and Ctrl V. So now next is put in the looping while true for R dot R equal to request dot get, and dictionary data is URL. Next is JSON data, JSON data r.text. This is the JSON, and for data is JSON the loop JSON data. So now we need to print the data. So for GPIO in data is state go to data. We use state because on this slide. So data GPIO. So if state equal to 0, print f GPIO is off, and then just copy and paste. If state is 1, this means it's on. So now we close the response, hard to close, and print. For the time is 1 second, so for the time is time.sleep is 1. So now let's try. Control save. Open this one. So before that we need to create for lamp1 is GPIO is 2 and create. For lamp2 GPIO is 14. Sorry, 12. Lamp 3 is GPIO is 14. So now let's try run. On, off. So now it's successful. Just Ctrl C to stop the program. So now we go to the MicroPython. For MicroPython, we use pin. So delete this one. We go to micro. For the MicroPython, we need to enable the pin anchor. That pin anchor. enable numerical and disable for Python. So now it's done. For MicroPython, we use ESP82. We use 826C. This is how to construct the LED. So now I use this one. Let me show you. So now I use 3 LED and ESP8268. So for LED 1, I use GPIO2. For LED 2, I use GPIO12 and 3 is GPIO40. So this is I was constructed. So now in the computer, before that I want to flash the ESP because it's made the ESP 8266 is small. The capacity is small, so I need to flash first. Open the USUF and flash. Wait for a while. So now it's done. So close it and open back. So for MicroPython, we need bootpy. Just copy on the link address on the USUF. Bootpy, copy link address and use the terminal. curl -0 file name is boot.py and paste. So bootpy file is here, and next is we need to BME file BME 280.py. Just copy and paste. So now another one file is me.py. This is the file that we need to create the program. Before that, we change it to the Wi-Fi or your hotspot. So for me, we use 0. So save and back to me.py. So for the LED, we use the permission to import I2C. So let's try. From class machine is from file machine. Import the class is E. And next is from the class is new time. Import we use the sleep import time to sleep because we need to create how fast we need to create I create for 50 or 10 seconds. So we use from JSON import loop because based on question we use the JSON data request and response activity. And next is from new request. Before that we need to in micro JSON import. Okay. So now for URL is copy back on here, Ctrl C, Ctrl V. And we create a while true. R get the URL in JSON data. Let's go to R dot text for dictionary data. For dictionary data is data equal to loop JSON data. Dictionary data is JSON data. So next is for GPIO in data LED we use pin INT in now is GPIO and pin out dot out. Next is state. We use state because on this link have state. So from state equal to data. The data is GPIO. So next is if state equal to 0 is mean the LED is off and print the GPIO know what number is off dot format number of GPIO. So just copy that and this we use elif state is 1, it means the LED is on and print the number of GPIO is off. So next is print and sleep. We use 15 sleep. Before that, we need to upload first on USB. Open the terminal. Upload for BNE first. Numerical. Upload. Numerical. Upload. So now we upload for boot PY. Before we upload for main PY, we need to make sure that Wi-Fi is connection. Before that, open the hotspot. And run. So connection is successful and upload for main PY. So now let's try run. Open the Yusuf. So now let's try run. Go and file. So now let's try run. For LAN 1 is on now. So for LAN 2 is on. And for LAN 3 is on. LAN 2 is closed, off. LAN 1 is off. LAN 3 is off. LAN 1 on. LAN 2 on. LAN 3 on. So that's all. So So that's all for GPIO. Let me screen capture first. So now let's do for the sensor. Control C for stop the program. So now let's go to the sensor. Now let's try to the task 5, which is sensor. By using the sensor, first we use the sensor Python cmd code dot automatically insert to VS Code. So before that, let's see on the question. For task 5 is write the Python program to prompt the random temperature, humidity and pressure and download the file dummy BME 280 and every 15 seconds. So let's try for the sensor. Open the terminal, new terminal. Before that, we need to enable the Python. Disable the FreeMaker and enable for Python. Enable for Python. So now let's try. Close and open back. Sorry, just open on here. New terminal. Copy from Yusuf.NET Tools module for the dummy. Copy and paste here. Wait. So type curl -0 and paste. Oh sorry, I forgot to put the file name. So curl -0 dummy bme 280.py and paste. So the file dummy is already. Now we need to create new file for main.py to type the program. So for the sensor, we use from dummy dme 280 on the class dummy. From object from the program of dummy, import class. Let's see what the class. So the class is dummy ESP280. Check. So input class is the dummy 280. So next is from time Nah, diam sikit. Next is from time import sleep. This is to create the time for 15 seconds. Import sleep. Next is from, we use JSON data. So JSON import dumps and from, and we use request and response activity. So for request import post. We use post because to send a post request to specific the URL. So first is URL. For URL, we copy on here. Sorry, we need to copy on here. Just copy, Ctrl C, and open back the chart. Ctrl V. So now the URL is already. So now we create the looping while true. For we use the T for sensor temperature. Is float. We use float because it's a number. So sensor dot temperature. So for property, we have temperature. Just copy. Just copy and paste. To flash the mark of unit, we need to use -1. So Control C, just copy and paste. Oh, before that, we use sensor dummy PME 280. So now sensor can read. So we copy, Control V, Control V. We have humidity, and the last is pressure. So for pressure, the unit have 3, so we need to flush the mark from the back is 3. So now for the data, we use the value. So for the data 1 is value, 1 is temperature, and we need to put the string for value 2 is for value 2 is humidity. Let's change it, humidity, and pressure is P. Humidity, and the value for value 3 is, we need to put string, value 3 is P. So now data is created. So next is we use JSON data equal to dumps JSON data equal to dumps and data we need to put this one. So now is print the JSON. Next is we use request header is equal to content type. For the content type, we can see on here visual sensor data. So for the content type, we use the value, and for the content type is just copy to avoid from the typo. put the string on content type and string on the application JSON. So now it's done. Close it. And now is for response R for response is equal to post. In the post we have the URL data, which is JSON data, and headers, which is request underscore headers. So now is print the r.text. Print the r status code first. And then print the text r.text and close. Print, and for the timer is sleep 50 seconds. So now let's check. Control Shift. Let's try. Bismillahirrahmanirrahim. Open the. Let's try run. So now the value is successful. Let's refresh. Yes, the data. Wait for a second. And wait for third reading. And we will continue the MicroPython. So now let's print screen first and stop. Control C to stop the program. So for the MicroPython, the coding is same, but a little bit change for the coding. So now let's try for the MicroPython. So before we continue for the coding, we need to open back the PMaker enable and disable for Python. Disable for Python. So now for this is for the task 6. So for the task 6, we use the ESP and BME280. So we need to insert the BME 280 file for every 50 seconds. So let's do it. Open the terminal. For the PMaker MicroPython, we need the file of bootpy and BME280. So first is we take the file of bootpy. So the file for bootpy is already. For the next is for the BME280.py. So now it's already. So for min.py to create the program. So for bootpy, we change the SSID for this is my hotspot. So depends on your hotspot lah to create it. So Control Shift. So now for this, how to clear this one, we need to insert on PHP. Sorry, just insert on here. To open back the PHP by admin to clear the graph. Wait for a while. Before that, we need to construct the ESP and BME on this link. So this is ESP and this is the sensor BME. For the SDA, we put on, let's see here. For SPA, GPIO4. For GPIO4 is D2. For GPIO5 is D1. So SCl on D1, and this is go to the VCC. For ground, go to the G, and this is USB. Just put on the desktop. Put in the desktop. So now it's successful. Open back to this one. It's take a long to get in, so I just continue with this graph. So let's do the coding. First is from the file BME, from the file BME to 80, import class. Import class. The class is BME to 80 also. So just type BME to 80. So next is we need to create the from queue time import sleep. This is for create the 50-second, and from machine import pin. We use pin of I2C cable, so I2C. And next is from, we use JSON data, so from JSON use JSON import dumps, and from we use request and response, so from you request import post. So now for the cable, we use I2C cable, so based on the file, we use I2C cable, so we use this one. So we put on comment, sorry, we put uncomment. So for cable, we use I2C cable, and for SCL is 4. For SCL is pin 5. For SDA is equal to pin 4. For the frequency is 100,000. We use 100,000 because this is how the ESPN BME280 is communicate. So next is for the sensor, we use BME280, and the dictionary data is cable. I2C cable, sorry. So now let's put the URL. For URL, just copy on here, API, Ctrl C, and open back the chart. Delete first. Put the string and Ctrl V. So now the URL is here. So next is we create the looping for the property. For that, for object, for while true, in the BME we have the property of temperature, pressure, and humidity. So for the T is float. We use float because it is the number. So for the sensor, temperature. To flash the unit, we need to flash like this. Control, copy, paste, and paste. Just change it for humidity and pressure. For pressure, it have 3 units on the back, so we put 3. So for the humidity we put H, and for pressure we put P. The next is data. For the data, we use the value. For value 1 is equal to T. Value 2 is, sorry, we need to use for value 2 is H, and for value 3 is P, pressure. So next is we create the JSON data is equal to dumps, and this dictionary data is data, and next is print the JSON data. Next is to create the request and response. So for the request, headers equal to content type. We can copy on here. Put the string on the content type. And application JSON. Okay, next we create the response. For response is equal to URL before the post, URL data is equal to, for object data equal to JSON data. And next is headers. For object headers is equal to request headers. So next is to print the response is response dot status code and print the response dot text. Next is we close the response. Response is closed. And the last is print, and for the timer is sleep in 50 seconds. So let's check first. Control Shift. So now let's connect for the ESP and sensor. Before that, we need to open the hotspot. So now we need to upload for PME. Upload for boot PY. Before we upload the main PY, we need to make sure that the hotspot is Wi-Fi is connected. So run the file. So successful. So now let's try upload. And we try to run. So new data is popped out. Let's wait for the next recording. For the second is run, and the recorded create is successful. Wait for the third. Now the third is successful also. So clear screen, and so that's all from me. Thank you.